Imagine this. You're sitting at a cafe sipping coffee and watching a cat video on your phone. It loads instantly. You scroll through Instagram, reply to a message, check your email, all within seconds. It feels magical, like the internet just floats around us, always there, like air. We even call it the cloud, right? But here's the weird part. That video, that message, that email, they didn't come from the sky. They came from the bottom of the ocean. That's not a metaphor. Beneath the surface of our planet, across thousands of kilometers of ocean floor lies a vast network of cables. Real physical fiber optic cables, thinner than a garden hose but carrying nearly all of the world's internet traffic. Yes, nearly 99% of international data doesn't travel by satellite or bounce around in some invisible cloud. It travels through wires laid like underwater spaghetti between continents. So here's the question. If we call it the cloud, why is the internet really just a cable? To answer that, we need to go on a journey. Not just across space from your phone to a server halfway across the globe, but also through time. Because the real story of the internet isn't about data flying through the air. It's about wires, it's about glass, it's about lasers. And it starts with something very unmagical, a cable plugged into the wall. Let's unravel the myth of the cloud and follow the real path your cat video takes. Let's start where the internet actually begins, at your device. When you open a website or play a video, your phone sends a signal to your home router. That router is connected to a modem which talks to your internet service provider. So far so good, it's all happening inside your house or building. But if the content you're asking for is hosted overseas, which it often is, your request needs to travel across the planet. Now, here's the fun part. Your data doesn't hop on a satellite and beam through space. That would actually be too slow. Satellites are tens of thousands of kilometers away. The delay would be noticeable. Instead, your request dives underground, or rather under the seabed. It finds a path through an invisible yet very real nervous system of our planet, submarine cables. These cables don't just connect cities, they connect continents. There's one from New York to London, another from California to Japan, dozens crossing the Atlantic and Pacific. Together, they form a global mesh of communication, almost like digital trade routes. Each cable can be thousands of kilometers long. And they're not thick and armored like you might imagine. Many are no wider than a garden hose. Inside them is a core made of glass. Yes, actual glass, optical fibers. Data travels through these fibers as pulses of light. That's right, your cat video is riding a laser beam through a glass thread at nearly the speed of light. Think about that. When you press play, photons carrying your request shoot through wires at up to 200,000 kilometers per second, reach a server on another continent, then bring the video back, all in less time than it takes you to blink. And yet we call it the cloud. Why? Because it sounds light and weightless. But the truth is, the internet has weight, it has structure. It has roots that run deep, not into the sky, but into the ocean. The cloud is actually a cable filled with light. But how does this light actually carry information? How do we go from a video stored on a server in Frankfurt to a moving image on your phone in Sao Paulo, all by shining light through glass? Here's where things get beautifully weird. The internet is really a story about turning thoughts into light, and light back into thoughts. It works using a very simple idea, on and off. That's it. Every bit of digital data, texts, images, music, this very video, is ultimately a long string of 1S and 0S. These 1S and 0S are like a secret code, and to transmit that code, we flash light on and off at insanely high speeds. It's like Morse code, but on steroids. Instead of tapping dots and dashes, we're blinking lasers millions of times per second. A light on might represent a 1. A light off might be a 0. These bursts travel through the glass fiber, bouncing their way forward without losing clarity. When they reach their destination, usually a massive server farm, the equipment reads those blinks and translates them back into digital information. That information then gets broken into tiny packets and sent to your device, where it's reassembled and played back. And here's the crazy part. The fiber optic cables are so efficient that a single cable, just one, can carry tens of terabits of data per second. That's enough to stream millions of HD videos at once. All of that riding on a thread of glass as thin as a human hair. Now, to keep that signal strong over long distances, we need repeaters. Little devices placed along the cable every 50 to 100 kilometers or so. These repeaters act like pit stops for the light. They catch the signal, clean it up, amplify it, and send it forward. Without them, the light would fade before crossing an ocean. So picture this. Your message is blinking through glass at the speed of light, diving through kilometers of water, stopping occasionally to refuel, then emerging on another continent, where it instantly gets decoded and answered. That's what's really happening every time you hit send. Not so cloudy now, is it? The cloud is a laser Morse code through underwater glass highways. Now that we know how data travels through light inside glass, let's zoom out and ask, how did these cables even get there? Who puts fiber optics at the bottom of the ocean? Here's the wild part. Laying an undersea internet cable is a bit like planting a garden hose between continents, except it's on the sea floor, thousands of meters deep and stretched over distances longer than entire countries. Specialized ships carry giant spools of cable, sometimes over 10,000 kilometers long. These ships sail slowly across the ocean, unspooling the cable behind them like an enormous mechanical spider spinning a web across the planet. When the ship nears the coast, things get even trickier. Divers or robotic submersibles are used to guide the cable to shore. Sometimes the cable is buried beneath the sand using pressurized water jets to protect it from anchors, trawling nets, and even shark bites. Yes, real sharks have chewed on internet cables. Apparently, they get curious about the electromagnetic fields around them. The planning for a new cable route can take years. Engineers have to study ocean currents, tectonic activity, and shipping lanes to choose a path that avoids natural hazards and human interference. They even scan the ocean floor with sonar to map out every bump and trench. In the end, it's not just a matter of technology. It's a logistical ballet performed on a planetary scale. Once the cable is in place, it's mostly left alone. But it doesn't mean it's invincible. Undersea cables do break. Earthquakes, fishing equipment, or even accidental drops of heavy anchors can snap them. When that happens, a repair ship is dispatched. It finds the broken end using GPS and special equipment, fishes it up from the seafloor, cuts and splices it with a new section, and lowers it back down. This whole process can take days or even weeks. And during that time, global internet traffic is rerouted through other cables. It's like if a lane on a highway goes down, the traffic detours through other roads. The internet doesn't stop. It just takes a different path. That's part of what makes this system so incredible. It's built to be invisible, robust, and always working in the background, no matter what. Now that we've seen how data becomes light and how light travels across the ocean floor, let's step back and ask, why do we even call it the cloud in the first place? The term cloud didn't come from engineers, it came from diagrams. In early network charts, the complex part of the internet, the stuff between your computer and a faraway server, was often drawn as a simple, fluffy cloud. It was a placeholder, a visual shortcut. It said, don't worry about what's in here. Just know that data goes in one side and comes out the other. And that's fine when you're just explaining a high-level idea. But over time, the word cloud stuck. It slipped into our language, our software, even our marketing. We started saying things like, store it in the cloud or run it from the cloud, as if the data were floating above us somewhere, ethereal, weightless, effortless. But now you know the truth. The cloud isn't fluffy. It's glass and lasers and underwater engineering. It's real, it's tangible. And it's powered by some of the most advanced infrastructure humanity has ever built. What's even cooler, every time you click a link or load a video, you're activating this massive system. In a fraction of a second, dozens of routers, switches, and cables work together to make sure your request finds the right destination and comes back with the answer. It's like sending a message in a bottle, except the bottle is a photon. The ocean is made of glass, and the round trip takes less than a blink. The internet might feel like magic, but it's not. It's science, it's logistics, it's engineering. And it works so well, so invisibly, that we forget it's even there. That's the real magic. So the next time someone says, it's stored in the cloud, you'll know the truth. That file isn't floating in the air. It's racing through a blinking laser inside a thread of glass, laid across the ocean floor by a ship the size of a football field. It travels through signal amplifiers, dodges tectonic faults, bypasses fishing nets, and arrives within milliseconds at your device. That's not magic, that's infrastructure. Global, invisible, and astonishing. We tend to think of the internet as abstract, some invisible force that just works. But in reality, it's one of the most physical things humans have ever built. It stretches across deserts, snakes under cities, plunges into the Mariana Trench and connects billions of people through a network of glass and light. The real internet isn't in the sky, it's in the dirt, in the ocean, in the walls around you. And that makes it even more impressive. Oh, understanding this changes the way you see your own connection to the world. That video you watched, that message you sent, that Zoom call, email, photo, or song. Each one was a tiny traveler in a high-speed underground and underwater maze. A pulse of light that bridged nations and continents to bring you what you wanted, when you wanted it. So let's retire the fluffy cloud metaphor. Let's appreciate the real internet, the one built with cables, lasers, and engineering brilliance. And if you loved uncovering this invisible world with us, don't forget to like the video, share it with a curious friend, and subscribe to How It Actually Works. Because here, we believe that the more you understand how the world works, the more magical it becomes.